Okay. Today we will start a new chapter. It is chemistry. Chapter number 4, chemical kinetics. Here, when we have discussed about the kinetics, then we need to discuss about the rate of the chemical reaction. Whether the reaction is complete with a smaller time durations, or whether the reactions will go for a long time durations to complete the reactions. That we call as a kinetics. So, in short, we can say that the branch of chemistry which deals with the rate of chemical reaction and the factors affecting the rate of the reaction and the mechanism of the reaction is called as a chemical kinetics. So, in the chemical kinetics, we need to discuss about the rate of a chemical reaction. Rate means the time occurs to complete the chemical reaction, that is rate. And factors affecting means that there are some substances which we added that substance to the chemical reaction, then we got the reactions to be complete quickly by decreasing the activation energy or by increasing the activation energy pathway, that we simply call as a catalyst. So the work of a catalyst is nothing to reach the activation energy quickly or to reduce the activation energy in a level so that all the reacting molecule can easily reach to the product. So this is what we call as this rate. So what are the factors which can affect on that rate? That is there, and how the reactions occurs. How the reactions occurs to get the products. That is what we call as a mechanism. So if we have discussed about the rate and factors of the rate and then the mechanism, then altogether that branches of science we call as a chemical kinetics. So in a chemical reaction, on the basis of the rate of the reaction, on the basis of the rate of a reaction, we can classify a chemical reaction into 3 types. First one, that is fast or instantaneous reaction. Fast or instantaneous reaction. And secondly, slow reactions. The third one is moderately slow reactions. So like this one, if we have discussed a chemical reaction based on the times occurs to complete the reaction, then we can classify a chemical reaction into 3 types. First, let us see what we mean by fast or instantaneous reaction. A chemical reactions which complete in less than 10 to the power minus 12 second. 10 to the power minus 12 second. Within that limit of time, if the reactions is completed, then the reaction is called as a fast reaction. So it is practically impossible to measure the speed of such reactions. That means it is practically impossible to determine the exact speed of a fast reaction. Now let us see what are some fast reactions example, that is ionic reaction. Reactions involving ions, say as an example Na plus Cl then to give NaCl. This is one of ionic reaction. Such an ionic reactions includes in the fast reaction. Next is organic substitution reactions. Suppose in benzene, if we put chlorine gases, then one of the hydrogen is replaced by, or one of the hydrogen is substituted by benzene to give chlorobenzene. So like this, such substitution reactions are included in the instantaneous reaction. So second type of reaction, that is what is slow reaction. The chemical reaction which complete in a long time from some minutes to some year. If the reaction goes some minutes or some longer time, that is year or months, then that is called as a slow reaction. Example of some slow reactions are as rusting of iron, transformation of diamonds, etc. And the third type, that is one of moderately slow reactions. If the time occurs is in between these two, that is one of fast and or instantaneous reaction or slow reaction. In between this, then it is called as a moderately slow reaction. So now this is the type of the chemical reactions based on the basis of rate of the chemical reaction. Now, what do you mean by a rate? Let us see it again. Now, the rate of a reaction. Say, if we buy some pen from the market, and then if we ask, what is the cost of this one? Then the owner says that it is of 5 rupees or 10 rupees. That means the exchange value for that pen, the ownership exchange value for the pen is rupees 5. Like this one, the rate of a reaction is the change in the concentration. Here in a chemical reaction, concentration changes. So, change in the concentration of any one of the reactant or product per unit time. It is a change in the concentration of any one of the reactant or product per unit time. Then that is called as a rate of a reaction. So, a rate of a reaction is defined as the change in the concentration of any one of the reactant or product per unit time. So, it is concentration terms. So, concentration term unit is moles per liter, and per unit time is the one of second inverse. So, it may be, the unit may be moles per liter per second, or molarity per second, or ATM per time units. These are the units of rate of a chemical reaction. So, the rate of a reaction may be decrease or increase of the concentration of the reactant or product per unit time. A rate of a reaction is equal to decrease or increase in the concentration of the reactant or product divided by time taken. Then we get the rate of a chemical reaction. So, the rate of a reaction is known as an average rate reaction, which we can solely represent as RAV. AV indicates the average here. RAV can be calculated by dividing the concentration difference by time interval. Then average rate can be found out by dividing the concentration difference, means that concentration of the initial minus concentration of the final divided by time taken. Then you will get the average rate for a chemical reaction. Now, let us see the reaction. AA plus BB gives CC plus DD. Here, average rate means that in terms of A. Generally, when we express the rate in terms of the reactant, then negative symbol should be there. As time goes on, the concentration of the reactant gradually decreases. If you want to express the rate in terms of the product, then the unit should be positive. Always remember, as time goes on, your product will be gradually increases. So, if you go to the product, then it should be, the symbol should be positive. If you go to the reactant, the symbol should be negative. So, here the stoichiometric characteristic 1 out of A will goes to the will changes, and here minus 1 by A delta concentration of A divided by delta T. This is the average rate expression in terms of A. If you want to express in terms of B, then minus 1 by B delta B by delta T. This is what in terms of B. If you want to express in terms of C, C is the product, so we need to write positive. 1 by C delta C by delta T. And if you want to write in terms of D, 1 by D delta D by delta T. So, here we can say that the A will be disappear. So, then the amount of the A gradually decrease by time. So, we can say the rate of disappearance of A. The rate of disappearance of A is equal to minus change in the concentration of A by delta T. Like this one, the rate of the disappearance of B, this is equal to minus delta B by T. If you want to find out C means it will appear more and more. So we can say the rate of appearance. The rate of appearance of C is equal to change in concentration of C by delta T. Same like this one, the rate of appearance of D is equal to delta D by delta T. Like this, we need to express a rate of a chemical reaction. How to express a chemical reaction rate? This is very important for the exam point of view. Always remember that stoichiometric coefficient should be converted into that per mole. That is why 1 by A, 1 by B, like this one. You need to change it. Now, We will see what we mean by instantaneous rate of reaction. Instantaneous rate of reaction. Instant means that for a particular time or a particular moment of time, that we call as an instant. So instantaneous rate is nothing, the rate of a chemical reaction at a particular moment of time. The rate of a chemical reaction at a particular moment of time that we call as an instantaneous rate of a reaction. So here, the term instantaneous, I already told that it is a particular moment of time. Suppose I want to discuss the change in the concentration of a chemical reaction for after 5 minutes. So 5 minutes is a particular time. So here we need to express the term instantaneous. The term instantaneous. So instantaneous rate means at any moment of the time, if you want to express the rate, then you need to use the term instantaneous. That is called as an instantaneous rate of a reaction. Instantaneous rate of a reaction. For an example, for the reaction R gives product, rate instantaneous is equal to, in terms of reactant, minus delta R by T. In terms of product, delta P by T. Like this one, if it is instantaneous, again, is this delta we can represent by D also. So here R instantaneous is equal to minus D concentration of the R divided by dt. Like this one, small d concentration of P divided by dt. Now, method for measuring the reaction rate. Number 1, pH measurement. This is the first method. And number 2, change in the optical activity. This is the second method. The third method, the change in the pressure. The fourth method, change in the conductance. We can measure by using this 4 method. We can measure a chemical reaction rate. So the slowest step of the reaction was called as rate determining step by Bainhoff. According to Bainhoff, each and every step, suppose the reaction occurs by passing through different steps. Out of that, each step has different rate. Out of that different rates, the one which is very slow will determine the overall reaction rate. So the overall reaction rate for a multi-steps reaction should be the smallest value of your rate. Now, that is why I say slowest step of a reaction was called the rate determining step. That is, it will determine the rate of overall reaction. Now, let us see about the factors affecting the rate of a reaction. Naturally, here is 2 factors. One is nature and the concentration of the reactant, and second one is temperature. Now, these are the factors. Now, let us see. Surface area of the reactant is another factor. And third one is radiation and catalyst. Fourth one is pressure of the gas. Now, let us see how a rate of the reaction depends on the concentration of the reactants. Suppose if the concentration of the reactant is more, then collision becomes more. The molecule collide quickly. When the molecule collide quickly, every collision will produce some amount of energy. Thereby, it will reach the activation energy quickly. Hence, the rate of the reaction becomes faster. Again, when we check the movement, the gaseous particle move more than liquid, then solid. So that is why we say first one, nature of the reactant means that gaseous reactants can combine quickly, then the liquid, then the solid. This indicates that nature of the gases is a factor of the rate of the reaction. Again, for the concentration, I have already told that larger is the concentration, the more is the collision. And thereby, it will reach the activation energy quickly. And after passing the activation energy, the reactant molecule goes into the product. That is why the concentration is more, the rate becomes more. Like this one, temperature. If temperature increases, force of attraction gradually decreases. If temperature increases, then the force of attractions gradually decreases. So, if force of attractions gradually decreases, then the molecular movement gradually increases. This increase in the molecular movement increases the rate of the collision. Hence, more product will be performed. So, for an exothermic reaction, decrease of temperature increase the rate, and for an endothermic reaction, increase of temperature increase the rate. So, it depends on the type of the reaction. Again, for the surface area of the reactants, if surface area is more, then the reaction become fast. If surface area is less, then the reaction become less. As an example, in our class 10, zinc, when combined with dilute acids, then we get salt and hydrogen gas. In this case, we use impure zinc. Why we need to take impure zinc? To increase the surface area. This example shows that increase of surface area of the reactant increases the rate of the reaction. So this is the third factor of rate of a chemical reaction. Now, like this one, radiation and presence of catalyst, and in case of gases, reactants, increase of pressure, increase the rate of collision, thereby increase the rate of the reaction. So all these are the factors affecting the rate of a chemical reaction. Now, what is rate law expression? Let us see. According to laws of mass action, so, let us take a reaction A, small a, capital A plus small b, capital B gives product. So, rate is directly proportional to concentration. This is what according to the rate law equations. So, we have A concentration of A here, B concentration of B here. So, if you want to equalize this into this one, then you need to get this proportional simple convert to equality. Then you need to put a constant K. So, rate is equal to K, concentration of A to the power A, concentration of B to the power B. But experimentally, it is observed that the rate of a reaction is found to depend upon the alpha. That is one of concentration term of A, and beta is the concentration term of B. So, it is not stochastic value, instead of stochastic value, if you use the alpha and the beta, that is the concentration terms. So rate is directly proportional to concentration of A to the power alpha and B to the power beta. This is equal to K, concentration of A to the power alpha, B to the power beta, where this bracket A and bracket B indicates the molar concentration of A and B respectively. K is the velocity constant or rate constant. The value K is what we call as a rate constant. So, what do you mean by rate constant, we can say, or what do you mean by velocity constant? Suppose, if you put this concentration is 1, this is 1. So, this concentration of A, means molar concentration is 1. Then, R is equal to K. This indicates that rate constant is the rate of a reaction, whose concentration is unity, whose concentration is unit concentration or unity. So rate constant may be defined as the specific rate of a reaction when the molar concentration of the reactant is taken as 1. Molar concentration is taken as 1. So now let us see the unit of rate constant K. K is equal to 1 by time into 1 by concentration to the power n minus 1. This is the unit of rate constant K. Now, what are the characteristics of rate constant? Greater the value of rate constant, the faster is the reaction. In the first one, greater the value of rate constant, the faster is the reaction. In the second point, each reaction has a particular value of rate constant. Each reaction has a particular value of rate constant at a particular temperature. And third point, the value of rate constant. The value of rate constant for the same reaction changes with temperature. That means rate constant value for the same reaction changes with change in temperature. And fourth point, the value of rate constant for a reaction does not depend upon the concentration of the reactant. The value of rate constant for a reaction does not depend on the concentration of the reactant. So it is independent of the concentration of the reactant, you can say. It is independent of the concentration terms of the reactants. These are characteristics of your rate constant. Now let us see the difference between order of reaction and molecularity. Difference between order of the reaction and the molecularity. So we have number one in the order. Order of a reaction is the sum of the concentration term. Order of reaction is the sum of the concentration term on which the rate of the reaction actually depends. Or we can say that it is also defined as the sum of the exponential term of the molar concentration in the Redlow equation. Suppose you write the Redlow equation, then you find out the concentration terms, that coefficient. If you added this exponent, if you added in the first case what? Alpha and beta are the exponential terms. So this alpha plus beta is called as a order of the reaction. Whereas molecularity means A plus B, small a plus b in the first equation. Molecularity is nothing, number of atoms or ions or molecules that must collide with one another to form the products. Means that actual number of atoms or molecules present in the reaction is called as a molecularity. Whereas that means molecularity you can see in the balanced chemical equation, whereas this order of the reaction you need to find out experimentally. This is what the part-1 difference. It can be fractional. This means order should be fractional or zero, but molecularity should never be fractional or zero. The value of molecularity should be always a whole number, whereas order may be fraction, may be zero, or may be whole numbers. And third point is, I have already told that order should be experimentally determined and molecularity should be theoretically determined. Now like this one, in the 4 point of difference, order of a reaction is applicable to elementary as well as complex reaction. Elementary means every one step reaction, or complex means 3-4 steps reaction. So order can be applied either in the single step reaction or multi-step reaction. Whereas molecularity should be applied only in elementary reaction, means single step reaction. And key point of difference is that negative order reaction is also possible. For order, negative value is also possible, but molecularity should never be negative. This is what about the difference between order and the molecularity. In the 5th point, we have different examples. Negative order reaction should be possible. Here, your NH3 and this one will have zero order reaction. Here, this two inversion of cane sugar and this and that are of first order reaction and second order reaction and third order reaction like this one. H2O gives water and half of oxygen. This is first order reaction. Like this one, second order reaction, twice H2, I2. So this is of second order reaction. Like this one, third order reactions here. 2 plus 1, we have third order like this one. And in the here only one molecule is here, so it is a unimolecule. Here 2 molecules are, it is a bimolecular. Here 3 molecules are there, it is why trimolecular. So molecularity will be expressed by your stoichiometric coefficient, and here you need to express your power. So NO2 power 2 plus O2 power 1, so 2 plus 1, 3. So it is of third order reactions like this. So this is what the difference between order and the molecularity. So next time we will discuss about the integrated Redlow equation for the zero order reactions. So this is the end of today's class. Thank you.